All right, so here we go, 8.2 and 8.3, which is proving triangles are similar by angle, angle, side, 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 and side, angle, side. Now, these notes are very similar to being congruent, except you have less theorems. That's why we did all of this together, because it made sense. All right, so let's start with what we're going to learn. So the essential question is, how do you prove that two triangles are similar? Well, you're going to prove it using one of these three theorems. And we're going to prove the slope criteria, and we're going to do some real life problems. All right, so here are the three proofs, or the three theorems. So we have angle-angle similarity, which means if two angles are congruent to two angles, then they are similar. They're not congruent, they are similar. So I'm going to go 1, 2, 3, 1, 2, 3. So triangle ABC is squiggly, similar to DEF. So here we would say if two angle pairs are congruent, then the third angle pair must be congruent because they have to add up to 180. All right, if the corresponding sides are proportional. So if the corresponding sides are proportional, so if I 1, 2, 3, 1, 2, 3. So AB goes with RS, BC goes with ST, and CA goes with TR. So ABC must be similar to RST. When you check the side lengths, they have to have the same scale factor. So this fraction equals this fraction equals this fraction, which has to equal your scale factor. So remember that K is your scale factor. And then the last one is side angle side, just like before. If you have a side and the angle that's between, side, angle, side. So if two sides and an angle are equal to two sides and the included angle, so for example, if angle X is equal to angle Y, or angle M, sorry, angle X and angle M, and ZX goes with MP, so let me do this, ZX goes with MP, and XY goes with MN, so see how this angle is between and this angle is between, so X, Y, Z is similar to M, N, P. So you have side, angle, side. So if I were to erase this a little bit where it's not so scribbly. All right. I'll go back over here. So I have side, angle, side, side, angle, side. All right, so let's do some questions. Okay, I don't know why. All right. So first we're going to determine whether they're similar, and if so, why, and then write our statement. So if this is 90 and this is 15, so 90 plus 15 is 105. So what's left over? So this would be 75 degrees. Okay, 90 plus 15 is 105. 180 minus 105 is 75. Well, if this is 90 and 75, then this is going to be 15. So these two are similar by angle, angle, because two angles are congruent to two angles. So triangle ABC is similar to EFD. Okay, so if I started with 90 degree, I got to start with 90. I went to the 15, to the 15, to the 75, to the 75. All right. In this case, I've got 44 and 30. So 44 plus 30 is 74. 180 minus 74 is 106. So this angle is 106. Here I have 116 plus 30, which is 146. 180 minus 146 is 34. So this angle is 34. Well, none of the angles except this match. So I only have one angle. These two do not match. So these two are not similar. And if they're not similar, then there's nothing else to state. All right, here, determine if they're similar. So this is going to be side, 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 because these three sides go with these three sides. So find your smallest side. So my smallest side over here is 4. My smallest side over here is this. This is old, this is new. So I'm going to go 2.5 over 4. So 2.5 over 4, so 2.5 over 4. 2.5 divided by 4. Math, enter. So it's 5 over 8. So this reduces to 5 over 8. Now find your largest. So my largest pairs with my largest. So new over old reduces to 6 divided by 8. Reduces to 3/4. Well, since these two are not the same, then these two are not similar. So if they are not the same, then they are not similar. And just to be sure, always maybe double check. So this is 5 over 7, which doesn't reduce. So I have a scale factor of 5 over 7, a scale factor of 3/4, and a scale factor of 5 over 8. They are not the same. Therefore, they are not similar. So check over here. So the smallest, so 12 divided by 15 is 2.4. So this is the smallest side, and 2.5 is the smallest side. So this is new, this is old. So 2.5 over 1. So 2.5 divided by 1, math, enter, is 5 over 2. So this reduces to 5 over 2. Let's see. 12 over 5. So this is really 2.4. So this is the largest side. So my largest side pairs with my largest side. So new over old. So 6 divided by 12 over 5. And I get math, enter. So turn your decimals into fractions. So far, so good. 5 over 2. And then this one pairs with this one. 5 over 2. Doesn't reduce because it's already there. So these sides are proportional to each other. So yes, these two are similar by side, side, side. 3 proportional parts. All right. Show that the two triangles are similar. Well, I have this big triangle ACE. So if you think about it, you've got ACE. So I do not know what just happened there. Okay, AEC. So that's the big triangle. And then you've got this little triangle right here. Okay. They both use angle C, so that's reflexive. So C equals C by reflexive. A is congruent to B because these two are parallel to each other. So these are corresponding. And then E is equal to D because they're corresponding. So yes, these two are similar. So yes, similar by angle. So angle C is congruent to angle C by reflexive. Angle A is congruent to angle CBD by corresponding angles. All right, over here I got all kinds of parallel. So always look for these parallel lines. So if this is parallel to this and this is my transversal, then this angle is equal to this one. And since this one's parallel to this one, this is congruent to this. So yes, these are similar by angle, angle as well. So you have alternate interior angles. Always look for those parallel lines because you get all kinds of congruency then. All right, this one, since this is parallel to this, then this angle is congruent to this one. This one is congruent to this one. And this angle is congruent to this one because they're vertical. So here I have alternate interior and vertical angles. So yes, these are similar by angle, angle also. And of course, SQ is equal to itself by reflexive. Don't forget that. All right, here we're going to use this diagram to complete. So what I always do when I'm doing these is I don't try to answer these questions. I just go over here and look at what I have, and I figure out everything that's missing, and then go back, because it's easier that way. So if this is 90, this is 90. Since this is 6 and this is 3, then this side over here, this is half. So since this whole thing is 3, then that means this is 1.5. This is 1.5. So if this is 3, and this whole thing is 6. So let's see. If this is 90 and this is 63, so I've got 90 plus 63, which is 153. 180 minus 153 is 27. So that means this angle is 27, this angle is 27, this angle is 27, 27, 63, 63. So the triangles are similar. And since it's a right triangle, if this is 3 and this is 6, then I can do Pythagorean Theorem. 3 squared plus 6 squared. So 9 plus 36. So the square root of 45. So the square root of 45 is 6.7. So this side is 6.7. So this side is 6.7. And I'll do the same thing over here. Well, actually, to be honest, if this is half, if this triangle is half of this one, then I can just take 6.7 and divide by 2. And I get 3.4, 3.35. So that means this is 3.35. So this one is 3.35. Now I know all the pieces. This is also 63. So AGB is 27 degrees. EGD, so EGD is 27 degrees. BCG is 63. AG is this piece here, we said was 6.7. AB is this piece here, which is 3. FE is 1.5. ED is 1.5. GF is 3.35. So triangle AGC is similar, so AGC. AGC. So I'm going to go with DGF. And you could have put FGD also. All right. So now we're going to determine if it's possible for these two triangles to be similar. So I'm just going to draw two triangles. So I have H, K, and J. So H, J, K. And then I have P, Q, R. So 1, 2, 3, 1, 2, 3. 1, 2, 3, 1, 2, 3. All right. So let's see. Angle H is 100. Angle K is 46. Angle P is 44. And angle Q is 46. So 100 plus 46, 180 minus 146. So that makes this 134. 44 plus 46 is 90, so that means this one is 90. not similar. Oops. So there are no congruent angles. So no congruent angles. All right, find the value. All right, so 1, 2, 3, 1, 2, 3. So R, S, T, H, G, K. So 1, 2 goes with 1, 2. So 1, 2 goes with 1, 2. 1, 3 goes with 1, 3. And 2, 3 goes with 2, 3. All right. So what are we going to do? Well, I know that 3 goes with x plus 7. I know that 3 minus x goes with 8. I can use this proportion and do a little cross multiplying and solving and factoring and all that good stuff. Or I could also do 3 goes with x plus 7, just like 5 goes with 20 over 3. So you can cross multiply and do it this way, or we can cross multiply and do it this way. I'm going to go with this one first, and we'll do this one in class. All right, so to go this way, I've got 5 times x plus 7. To go this way is 3 times 20 over 3. So this is 5x plus 35 equals 20. Because 3 times 20 is 60. 60 divided by 3 is 20. So subtract 35. I get that 5x is negative 15. So x is negative 3. So we go through and let's see. All right, so we're finding out that x is negative 3. All right, so what is x? X is negative 3. So if I plug negative 3 in, so I've got 3 minus negative 3, which means 3 plus 3. So this side is 6. Negative 3 plus 7 is 4. So RT is 1, 3. So RT is 6. GH is 4. All right. This one looks like it was going to be more confusing because of that stinking fraction, but actually this part right here is a little bit more work, but we are going to do it in class. So make sure you write the formula or the proportion down so that we can do it in class. All right, verify that the triangles are similar. So RST, so triangle RST and triangle XYZ. So R goes with X, S goes with Y, Z goes with X. See, it doesn't matter how you twist and turn them as long as you make sure they have the right labels. So RS is 12, ST is 15, TR is 24, XY is 28, YZ is 35, and this is 56. So find your smallest, pair it with your smallest. So find the scale factor. So this one is old, this one is new. So I'm going to go 28 over 12. So 28 divided by 12, math, enter. So I get 7 over 3. So now I'm going to do my largest. So this is my largest side, goes with my largest side. So 56 over 24, reduce. And it reduces to 7 over 3 as well. So far, so good. And then, of course, check 35 over 15. Well, 5 goes in 7 times, 5 goes in 3 times. and I see that they all have the same scale factor. So there you go. Scale factor is 7/3. If they didn't have the same scale factor, they would not have been similar. All right. Of RS. Okay. I guess scale factor. So this is old, this is new. Yeah. All right. 21. The shortest side of a triangle is similar to triangle ABC. It's 15 units long. Find the other sides of the triangle. So here we've got ABC. So find the other side lengths of the triangle. So what they're going to do is you're going to use this triangle, and then you're going to have another triangle that's similar. So the shortest side of a triangle similar to this one is 15. So let's go with LM, LMN. Okay. So if ABC, so let's go 1, 2, 3, 1, 2, 3. So this is the shortest, this is the longest, this is the middle. The shortest side of a triangle similar is 15. Well, this is 15. So 6 goes with 15, just like 7 is going to go with medium. So this is our medium side, or our middle side. So cross multiply, 6 medium is 15 times 7, so it's 105, and then divide by 6. So I'll find out that the middle side is 17.5. So this is 17.5. I'm going to call this the big side, or the largest side, I guess. We'll call this largest. I should have chose different letters. Let's rename this. Let's call it X, Y, and Z. Let's call it X, Y, and Z where we don't get L's and M's confused. All right. So going back. So the middle side is 17.5. Now the longest side, so again, 15 is going to go with 6, just like the large side is going to go with 9. So 6L equals 15 times 9 is 135. And divide by 6. And we get that the largest side is 22.5. So this side is 22.5. All right, so same triangle, small, medium, and large. Now the longest side of a triangle similar. So now we have this triangle over here. So we will call this, how about RST? No, no S's. Okay, let's just go with X, Y, Z again. X, Y, and Z. So the longest side, so we'll call XZ the longest side, is 6. So we need to find the medium side. So we'll call this the short side, and we'll call this the medium side. So I'm going to block this off and change colors. All right, so the longest side goes with the longest side, just like the shortest side goes with the shortest side. So 9S equals 36. So the shortest side is 4. So the shortest side on this one is 4. Just same thing. This is the longest side of a triangle similar to triangle ABC is 6. So this is the longest side. All right, so 6 goes with 9, just like middle goes with 7. So 9M is equal to 42. Divide both sides by 9. So 42 divided by 9 is 14 over 3, or 4 points. So it's 4.6 repeating. So this side is 4.6 with a repeating decimal. All right. So it's all about matching small with small, medium with medium, long with long. All right. Last one. A flagpole casts a shadow that is 50 feet long. So sometimes you're going to have to draw pictures. So a flagpole casts a shadow, because shadows are on the ground, so 50 feet long shadow. At the same time, a woman standing nearby. So we got us a girl over here. She's standing nearby who is 5 feet 4 inches. So she's 5 feet 4 inches tall. She casts a shadow that is 40 inches. Now, how tall is the flagpole? So I want to know how tall the flagpole is in feet. Well, since she is measured in feet and inches, but her shadow is inches, let's convert her to inches. So there are 5 feet times 12 inches is 60, plus those 4 extras. So she is 64 inches. All right, so we're going to change her to 64 inches. Now, as long as you have 2 of one increment and 2 of another, you don't have to convert everything. So you can have 2 and 2. So I'm going to go, well, the height of the flagpole goes with the height of the girl, so feet in inches, just like the shadow of the flagpole, goes with the shadow of the girl. So now when I cross multiply, I get 40x equals, and then 64 times 50 is 3,200, and then divide by 40. And you get 80. So x is 80. So that means the height of the flagpole is 80 feet. So I didn't have to convert everything to inches or everything to feet. As long as you have 2 in feet and 2 in inches, you're okay. Or 2 in meters and 2 in centimeters, and so on and so on. As long as you have 2 of each, it will work itself out. All right, I will see y'all in class. Have a great night.